Two people. Same investment strategy. Same rate of return. Alex invests $5,000 a year, starting at age 20. He does this for exactly 10 years, then stops completely. He never invests another dollar. Brian starts at 30. He invests that same $5,000 every year and for 35 years. He never misses a contribution. At age 65, Alex has $2,463,000. Brian has $1,490,000. Alex has nearly $1 million more, despite contributing $125,000 less. This is not a trick. This is mathematics. And in the next 12 minutes, you will understand exactly why. Let's define the concept precisely, because most people learn it wrong. Take $10,000. Invest it at 10% per year for 30 years. With simple interest, you earn 10% on your original deposit every single year. 10 years in, you have $20,000. 30 years in, $40,000. The growth is perfectly linear, a straight line. Compound interest works differently. You earn interest on your deposit. Then next year, you earn interest on your deposit, plus C, the interest you already earned. Interest on interest, every single cycle. Same $10,000, same 10%, same 30 years, with compound interest, $174,494. That's a difference of $134,000 from the same starting amount, the same rate, the same time period. Warren Buffett called it the snowball. The longer the hill, the bigger the snowball grows. Not by the same amount each year, but by an accelerating amount. The growth doesn't add, it multiplies. The formula is elegant in its simplicity. A equals P, multiplied by the quantity 1 plus R, raised to the power of T. A, the amount you end up with. P, your principal, the money you put in. R, your annual rate of return, expressed as a decimal. T, time, measured in years. Notice where time lives in this equation. It's the exponent, not a multiplier, an exponent. When a variable becomes an exponent, it doesn't scale your result linearly, it scales it exponentially. Increase R from 10 to 12%. Your result grows. Increase T from 20 to 30 years. Your result does something entirely different. In our example, $10,000 at 10% for 30 years. 1.1 raised to the 30 equals 17.4. Multiply that by 10,000. $174,000. The mathematics of compounding is not complicated. What makes it powerful is time. There's a mental shortcut that every serious investor knows. The rule of 72. Divide 72 by your annual rate of return, and you get the approximate number of years it takes for your money to double. At 4%, it doubles every 18 years. At 7%, every 10 years. At 10%, every 7.2 years. 10% is the long-run historical average of the S&P 500, including dividends reinvested across nearly a century of data through crashes, recessions, and recoveries. So at 10%, your money doubles every 7 years. Here's what that means in practice. You invest $10,000 today, do nothing. In 7 years, $20,000. At 14, $40,000. At 21, $80,000. At 29, $160,000. At 36, $320,000. At 43 years, $640,000. Same $10,000. 0 additional contributions. 6 doublings. The returns in the final years dwarf everything that came before, because each doubling builds on the entire accumulated base, not just your original deposit. The rate of return matters, but perhaps not in the way most people think. Here are 4 scenarios. Same $10,000, same 40 years, 4 different rates. At 4%, the kind of return you'd see from a standard savings account or short-term government bonds, you end up with $48,000. Real growth, but barely 5 times your starting amount after 4 decades. At 7%, closer to a globally diversified bond and equity portfolio, $149,000. At 10%, the historical S&P 500 average, $452,000, 45 times your original investment. At 12%, 400 extra basis points above the 10% benchmark, $930,000. Almost $1 million from a single $10,000 investment. The difference between 4% and 10%, same money, same time, is $400,000. Rate matters. But notice, the shape of the curve at 10% and 12% is nearly identical in appearance. Both are exponential. Both accelerate sharply. The lesson isn't chase higher returns at any cost. The lesson is get into the exponential function as early as possible. Let's run through this slowly, because the details matter. Alex begins at 20, $5,000 a year. He does this faithfully every year, from age 20 to age 29, 10 contributions, 10 years. At the end of that decade, his portfolio sits at $87,656. Then, at age 30, Alex stops. Not because he runs out of money, not because the market crashed. He simply stops contributing. The money stays invested. Brian starts at 30. Same $5,000 per year. And unlike Alex, Brian never stops. 35 years of contributions, all the way to 65. Now here is where most people expect the story to end differently. Brian works harder. Brian is more disciplined. Brian invests 3.5 times more money. Surely Brian wins. He doesn't. At age 50, Alex has $589,000. Brian has $349,000. The gap is widening, not closing. At 65, Alex, $2,463,000. Brian, $1,490,000. Alex wins by nearly $1 million. And here is the most important number in this entire video. Alex's very first contribution, $5,000 invested at age 20, by age 65, that single deposit alone grew to $364,000, 45 years of compounding, untouched. That's more than Brian's entire first decade of contributions. This is not a strategy. This is a mathematical law. The earlier a dollar enters the compound interest equation, the longer its exponent, and the more explosive its ultimate contribution to your wealth. There's another way to see this, in terms of the price you pay for waiting. Suppose your goal is $1 million by age 65. You plan to make a single lump sum investment today and leave it alone. At age 20, you need to invest $13,719. That's it. One investment. Let time do the rest. At age 30, you need $35,584. More than double. At age 40, $92,296. The goal is identical. The return is identical. The only difference is the starting age. Waiting 10 years past age 20 costs you $22,000 in required capital. For the same result. Waiting 20 years costs you nearly $80,000 more. This is the price of procrastination, expressed not in motivation, but in mathematics. Theory is useful, but here is what $500 a month, roughly $16 a day, actually becomes over time, invested in a broad market index fund at the historical 10% annual average. 10 years, $102,000. You contributed $60,000. The market gave you $42,000 on top. 20 years, $379,000. You contributed $120,000. The market doubled it. 30 years, $1,130,000. You crossed the $1 million threshold with a $500 monthly contribution. You put in $180,000. Compounding turned it into 6 times that. 40 years, $3,162,000. Your total contribution, $240,000. The market contributed $2,922,000. Money you never earned, never worked for, never saved. At 40 years, for every dollar you contributed, compounding added $12.17 on top. That is not a return on investment. That is a return on time. Warren Buffett bought his first stock at age 11. He has been investing without interruption for over 80 years. At age 30, $1 million. At age 50, $300 million. A remarkable figure by any measure, but barely visible on the chart of his final wealth. At age 60, $3.8 billion. At 65, the age most people plan to retire, Buffett had less than $4 billion. Today, at 93, he has $119 billion. 99% of Warren Buffett's wealth was accumulated after the age of 52. Not because 52 was when he became smart. He was extraordinarily skilled by 30. Not because the market improved dramatically. It has always had its cycles. It is because at 52, after 41 years of uninterrupted compounding, the exponential function finally delivered its promised acceleration. The long hill, the wet snow, the snowball became an avalanche. Buffett has said, "My life has been a product of compound interest. Not stocks, not genius, not timing. Compound interest, and the patience to let it run." 3 things worth remembering. 72. Divided by your rate of return. That's how many years it takes for your money to double. No calculator required. Every decade you delay is not just time lost. It is a multiplier applied to the amount you must contribute to reach the same destination. And Alex and Brian, they had the same strategy, the same rate of return, the same retirement age. The only variable was when they started. The mathematics of compound interest doesn't reward intelligence, or discipline, or sacrifice. It rewards time. Thank you for watching.